Hey, welcome to Unit 6-9, Solving Quadratic Word Problems, Part 2 here. This time we're going to talk about area. Area such as area of a garden or area of a fenced yard or area of a rectangle, just to be general there. So, today we're going to review methods of solving quadratic word problems, focusing on area. Previously was maximums and minimums about things moving. So, follow along with this one here. Let's take a look. The length of a rectangular garden is 6 yards greater than the width. The area of the garden is 72 square yards. Find the dimensions of the garden. Well, right off the bat, the first thing you're going to notice here in the first sentence is you have the word rectangular. So here's a hint for you. Always sketch geometric shapes in word problems. As soon as you see the rectangular, circular, triangle, whatever, just get a piece of scratch paper and sketch that real fast, okay? Alright, now, let's fill in what we know about this rectangular garden. We know that the area is 72 square yards. So we're going to go ahead and label that. The width, W equals, L equals, we're not really sure what's going on. Let's go back and reread it. The length of a rectangular garden is 6 yards greater than the width. Well, the width is pretty standard. It's just going to be W for the width. We don't really know anything about the width other than that. But what about the length? What do we know about the length? Well, the length is the width plus 6 more yards. Whatever W is, you're going to take the letter W there and add 6 to it, and that'll be the length. So we're going to use that in place of L. Alright, so what do we know? We know that the area of a rectangle is length times width. So we'll go ahead and take W times W plus 6, and we're going to use that fact to solve. So W times the quantity W plus 6 equals 72. And now, let's just do what we know how to do here. First things first, of course, is to distribute. So the distributive property yields W squared plus 6W equals 72. Now what do you think's next? Next, we should maybe set our quadratic equation equal to 0. Remember, your best friend in Algebra 1 is the number 0. He'll help you out quite a bit, so use whenever you can. So we'll set that equal to 0. And now, to find zeros, of course, we can use the quadratic formula. So let's go ahead and plug in the quadratic formula here. Just for ease of use, because we have x kind of embedded in us in the formula, we'll just replace W with x here for ease of use with our formula. So our A term is 1, our B term is 6, and our C term is negative 72. Remember your song? There's your formula. If you write it down each time you use it, you'll always remember it. And let's go ahead and plug in our values here. So we have the opposite of B is negative 6 plus or minus 6 squared minus 4 times A times C over 2A. Let's do some quick math. Clean this up, and we get 36 plus 288 inside the radical. And that's going to clean us up to the square root of 324. So square root of 324, if you remember that from Unit 1, square root of 324, if you're not sure, grab a calculator. It's going to be 18. Nice friendly number. Again, we get two distinct equations here, negative 6 plus 18, negative 6 minus 18, both of them divided by 2. Alright, let's do some quick math. Negative 6 plus 18 over 2 gives us 12 over 2, which is a nice whole number of 6. What about the one on the right side? Negative 6 minus 18, negative 24 over 2. Well, however you cut that, we're going to end up with a negative number here. What are we talking about? We're talking about distance. Distance, of course, cannot be anything lower than 0, so we're going to end up with an extraneous solution right there on that side. Negative 24 over 2 cannot possibly work. So that leaves us with a width of 6. If the width of 6, going back to our equation, our statement there at the beginning, the length should be 12. The length of a rectangular garden is 6 yards greater than the width. Well, if the width is 6, then the length has to be 12, and now you found your dimensions. And we know, of course, 12 times 6 is 72. Alright then, how about one for you now? One for you. The length of a huge rectangular portrait frame is 6 feet less than 3 times the width. The area of the portrait frame is 9 square feet. Find the dimensions of the frame. So we've got this big monstrous portrait frame. You've seen these in big, maybe in big living rooms or great rooms, and they have a family member or a group of people in the family, and they have this portrait done. We have this huge portrait here, and we want to find the dimensions of this frame. Okay, so let's take a look. So we know that the area is 9 square feet. We're not sure about the width and the length though. That's kind of unknown. But go back to the beginning here. Again, we have some information about the length, don't we? The width is just going to be the width, but the length is 6 feet less than 3 times the width. So you can see right there on the left-hand side, I've got this. It's 6 feet less than, remember that's subtraction, than 3 times whatever the width is. All right, now what do we know about area? Well, area is, of course, length times width. So we're going to use the dimensions we found. W multiplied by 3W minus 6 equals 9. And let's just go to work. So let's use the distributive property like we did previously. And take off from there and see what you can do to find our dimensions of our portrait. Alright then, hopefully from this point here, you might have set the quadratic equation equal to 0. And if you take a look at that, we have 3w squared minus 6w minus 9. You could think x box, or maybe simplifying an easy x, or remember, you can always use the quadratic formula to find zeros. Just drop those numbers in there and get to work. So right here, we'll let a equal 3, b equals negative 6, c equal negative 9. Remember your song, write down your quadratic formula, plug in the values, and just go to work there. You've got 6 plus or minus the square root of negative 6 squared minus 4 times 3 times negative 9 all over 2 times 3. Remember, in that radical sign, after you square the negative 6, multiply backwards, and you end up with 36 plus 108 inside the radical sign there. Alright, let's go ahead and clean that one up. 36 plus 108, what do you get? Did you get 144? And we know the square root of 144 is 12, so that's going to be a nice friendly number again. Will they always be nice, perfect numbers? No, but for sake of word problems and Algebra 1, they're going to play nice for a while. Algebra 2, well, all bets are off there. They can be as complicated as they want to then. But for now, they'll probably keep things pretty straightforward. 6 plus or minus 12 over 6. Let's take a look at what we got. 6 plus 12 over 6. Remember, don't get loose and start canceling sixes and come up with that. Stay disciplined. Reduce the top first, simplify the top, then divide. Okay? Order of operations. All right, 6 plus 12 over 6. That, of course, is 18 over 6, which is going to end up being, well, that is not correct. It's not going to be 6. It's going to end up being 3 there. Let me fix that real quick in lieu of doing everything over. So we'll cross this out. 3. Sorry about that typo there. And then over here, what are we going to end up with? Well, we're going to end up with negative 6 over 6. And negative 6 divided by 6? Well, that's going to yield us with a negative 1. Does negative 1, does that seem right when we're talking about a distance or measuring something? No, so this one here, we're going to call this one an extraneous solution here. So this one is out. So what's going to be our width here? Well, our width is going to be 3. Width is going to be 3. All right, let's take that and plug it back into what we know. And if you all close your eyes here for a second, you won't see any of the little typos I made there. Anyway, if the width is 3, then the length has to be 3. And how do we know that? Well, we know that the area was 9. So if the width is 3, then the length is 3. Or you can plug it back in and say 6 feet less than 3 times the width and get the same result. All right, very good. So it looks like we have a square portrait frame there, doesn't it? Remember that all squares are rectangles, but not all rectangles are squares. So the test writers and the people doing that, they can get away with that, saying it's a rectangular portrait frame and have it actually be square. That's not cheating. A little tricky, but not cheating. All right, here's the summary for you. Let's see. Make sure that you remember to sketch geometric shapes. Sketch geometric shapes, okay, whenever you see them. Assign known dimensions, and then try to simplify. So plug in what you know, and then figure out, well, how do I find area, how do I find circumference, or whatever they're asking you to do. And use the easiest method to solve. Quadratic formula, easy x, whatever you want to work with, whatever you find the easiest to use. You have lots of tools at your disposal now, so use what you like. Quadratic formula will always work when finding zeros. Always remember that. And make sure you answer the exact question asked. Sometimes you'll be asked a series of questions or a question, and you'll get lost at the end, and you'll come up with an answer, but you didn't answer the exact question that the paper asked you or the person asked you. So make sure you do that, okay? All right, that's it for Unit 6-9. We'll be practicing them together, and we'll talk to you soon.